This video lesson is going to show you how to graph quadratic functions when the value of a is not equal to 1. So just to recap, we have learned that there are 3 different forms of a quadratic function. So the first one is standard form, and standard form is obviously useful, and it's called standard form for a reason. Standard form is when we have ax squared plus bx plus c. And this is the form that we need if we are factoring or trying to do completing the square. So that's standard form. Next up we have vertex form. And we like vertex form. That's a fan favorite. And that one is very helpful because we can look at the equation and identify the vertex right here. Then we have intercept form, and intercept form is helpful because we can look at intercept form. It looks like this, and we can identify what our x-intercepts are, which makes it very useful when we are trying to graph. So what we've done so far is we've looked at these different forms. We've learned how we can figure out what the vertex or where the vertex is located, as well as the axis of symmetry. And then we've learned that the quadratic function makes a parabola on a graph, and we know what that looks like when a equals 1. So what we're going to do today is look at what happens when a is something other than 1. So you're going to want a piece of graph paper to go along with this. You can sketch it on your notebook paper as well. Graph paper is usually pretty easy though. So if you need to pause the video to get yourself a piece of graph paper, then please do. And I'm going to zoom out just a little bit. So I've made mine actually pretty rectangular, and I am going to make this vertical, and I'm just going to start setting this up with an x and a y-axis. So again, if you need to pause the video so that you can get yourself some graph paper and get it set up, then please do. So in a previous video, we have learned what a standard parabola looks like, and I think I mentioned that it's called the parent graph. So if we have a parabola that is centered at the origin and the value of a is 1, then we know what's happening is that when we fill in an x, we're squaring it. So if we fill in x and square it, so fill in 1, we get 1. If we fill in 2, we get 4. If we fill in 3, we get 9, which I think I counted right. If we were to fill in 4, we would get 16. That's off of my graph. Then we learned that there's an axis of symmetry, which is an imaginary line that runs right through the vertex. So it's located right here. And I'm kind of making it a dashed line because it's not an actual part of the graph. It's not a physical part of the graph. It is an imaginary line, but it provides us the fold line, the symmetry. So we know that these points over here have mirror images over here. The reason why that happens is because if we square -1, we still get 1. If we square -2, we get 4. If we square -3, we still get a +9. So this is what we've learned in a previous video. So I did not do a good job on my on my parabola here, but we'll pretend that that looks pretty good. So this is a standard parabola where y equals x squared. So the value of a is just 1. So what we're going to do is look at what happens when that value of a is something different. And what is basically the bottom line going to happen is that when we have a number in front of our x squared, after we square our x value, we're going to multiply it by that number. So this is going to affect how many points or how many spaces we go up or even down. I'm going to show you that in a minute also. So let's start off with y equals 2x squared. So what's going to happen with y equals 2x squared? So let's see. I guess we can call this example 1. So let's say we have y equals 2x squared. Since a is 2, this is going to make our parabola 2 times taller. So if we go over to our graph, what's going to happen is our vertex is still 0, 0. When I fill in 1 for x, so fill in 1 for x, I square it, I get 1. So a normal parabola would go over 1, up 1. But this time we're going over 1 and up 2. All right, now let's fill in 2 for x. If we fill in 2 for x, we square it, we get 4, but we have to multiply that by 2, which means we're going to go up 8. So what's happening is this number right here is making our points 2 times taller than a normal parabola would be. But same thing's going to happen because we still have this axis of symmetry. We're still going to have mirror image points, but just to show you, if we fill in -1, so -1 squared would be 1. That's a normal parabola, but this one's going to be twice as tall. So if we fill in -2, -2 squared would be 4, but this one's going to be 8 because it's going to be twice as tall. So when we multiply by 2, we get a taller, thinner parabola. All right, let's try, let me grab a different color here. Let's do, let's see, for this one, what if we do 3x squared? So if you've caught on, we're going to do a basic parabola, but it's going to be 3 times taller. All right, so here we go. So still centered at the origin. All right, normally we would go over 1 and up 1, but this time if we fill in 1, we're going to go up 3. All right, if we fill in 2, squared would be 4, but we need to go up 12. So let's see. So this should be 8, 9, 10, 11, 12. Oh, I do have space. All right, and then same thing, we know that this is the axis of symmetry, which is a line of symmetry. So this is our fold line. So this point has a mirror image over here, and this one has a mirror image over here. So now if we connect these points, our parabola is even taller and thinner than our previous one. Oh, I meant to label these. So this is 3x squared, and then this red one was 2x squared. So what we're doing is we are changing the height of our parabola. All right, so let's think about this, and I know you can't really answer me, so we'll pretend. For example 3, what if we had y equals 1/2 x squared? So y equals, 1/2 x squared. All right. Well, hopefully you know that it's going to follow the same pattern. So this time, yikes, this pen is not very good. So this time our parabola is going to be half as tall. Yikes. Because if we're, again, starting at 0, 0, if we go over 1, a normal parabola would go up 1, but this time we're going to go up 1 and, over 1 and up just a half. All right, a normal parabola would go over 2 and up 4, but if we fill in 2, half of that, we're only going to go up 2 spaces. All right, a normal one would go over 3 and up 9. So this one's going to go over 3 and up 4.5 points. And then this one we can actually fit. A normal parabola would go over 4 and up 16, but this one's going to go over 4 and only up half of that, which is up 8. And then we know we have this axis of symmetry right here, so we have mirror image points for all of these on the negative side of the graph. And that's because if we fill in a negative, so let's just try it. If we filled in -3, we square it, we get 9, but half of that is going to be 4.5. So what's happening now, yikes, is, and again, I'm not very good at drawing my parabolas there, but this one is wider because it's half of the height. All right. So I think hopefully you're getting the idea of that. So let's talk about what happens if the value of A was negative. All right, let's see. We'll do a pink. All right, so for example 4, what if we had y equals negative x squared? All right, now first of all, probably need to remind you that this is the same as -1 x squared. So order of operations says that we need to do the exponents first and then multiply by -1. All right, I don't know, can you take a guess? All right, we'll see if you're right. All right, so this one, we're still going to start, our vertex is 0, 0 here. So starting at 0, 0. All right, if we fill in 1 squared would be 1, but it's negative. All right, if we go over 2, a normal parabola would go up 4, but this one is going to go down 4. So hopefully what you're realizing is that this negative right here causes this to reflect over the x-axis. All right, so if we tried 3 squared would be 9, but it's going to go down 9 instead of up 9. So I think I counted correctly there. And then still we have this axis of symmetry right here, so I have mirror image points of all of these on here. So when a parabola has an A value that is negative, it's going to be reflected over the x-axis. So instead of going up, it's going to go down. All right. So let's see if we can try one last one. Hopefully we have time for this. So example 5, what is going to happen if we have -2x squared? All right, so let's try it out. So still at 0, 0. All right, if we fill in 1 for x, 1 squared would be 1, but this one is going to be multiplied by -2, so it's -2. Aha, so here's what's happening, is this one is not only reflected, so it's reflected, it's also stretched to be 2 times taller. So if we fill in 2 squared would be 4, multiplied by -2 is going to be -8. So this one is going to go down and it's going to be taller and thinner. So again, we have those mirror image points around the axis of symmetry. So here is our, and I forgot to label this one, y equals -2x squared, and the other one. All right, so this video needs to stop for time, so I'm going to pick up in the next video by working through some examples.